We talked already about the importance of understanding our units, and now we're going to look into them just a little bit more. Every measurement has a base unit in the metric system, and note that just because we're dealing with volume, for example, where here our metric base unit is the liter, symbol of L, that doesn't mean that we're always going to be dealing with liters specifically. It could be milliliters, it could be microliters. We'll get to that pretty soon, but the basis of all of these is the liter. And I think that when you're dealing with units, the first thing that you want to notice is what fundamental type of measurement is this unit dealing with. Length has a base unit of meters, and if it's kilometers, kilometers, centimeters, or just meters, these deal with length. We often deal with length in terms of feet in the English or imperial scale, but in science we pretty much always use the metric system, and meters is a measure of length in the metric system. Mass, we dealt with grams, we dealt with milligrams previously. Base of grams, milli means 1,000th of a gram, basically. So that prefix is going to modify what this base unit is. But for now, these are our base units, really fundamental stuff. When we hear meters or see the symbol little m, we want to think this is measuring length. If we see grams, symbol of lowercase g, that's measuring a mass. Liters, capital L, quantity of volume. And the capitalization here matters as well. These are worldwide conventions. Here are our prefixes, right? And so again, if we're trying to measure the amount of water in the ocean, right, or the amount of water in a pool, right, we don't really want to use milliliters. We might want to use kiloliters, I guess, or that might not be a perfect example. Let's consider the distance between where we are now and where we're going in our car that's, a 20-minute drive away. Well, we could say, yeah, that's 30,000 meters away. That's totally fine to do. But better than that is to say that's 30 kilometers, right? 1 kilometer is 1,000 meters. That's what the definition of the kilo prefix is here. So instead of having to say 30,000 meters, we can simply say 30 kilometers. If a patient has a mass of 70 kilograms, right, we could say, sure, you're 70,000 grams, but easier is to say 70 kilograms. These prefixes really exist to bring numbers into a scale that we can kind of hold and understand a little bit better. They're meant to make our life easier in reality. So applying them and seeing how they're used is another really, really important thing in healthcare. Again, if we're supposed to get a 2-liter bag of saline and we're looking around for one that's 2 milliliters mistakenly, that would be a very different look, right? And that might not be a practical example, but it is to draw attention to the fact that these matter a lot. 2-liter bag, that's like, a big bottle of soda is a 2-liter bottle. 2 milliliters is, like would fit in the palm of your hand. Very different amounts of volume, even though they have the same number. And again, right, tiny mistake can have big consequences. 0.5 milligrams of medication is interpreted as 0.5 grams. This is a huge mistake because remember, a milligram is 1,000th of a gram. So if we're giving grams when we should be giving milligrams, that patient will be administered 1,000 times more than they're supposed to. That could easily result in death or something like that. Okay, why does this matter even if the measurement seems small? Sometimes it's good to pause and think through these videos. Why does this matter a lot? The measurement is small, 0.5 in each case. What's the difference between grams and milligrams? And the answer here, right, is that grams is always 1,000 times bigger than milligrams as far as the actual quantity. 5 milligrams would be if we had 5 grams, that's 1,000 times more than 5 milligrams. If we're saying an amount that is 5 milligrams, that's actually 0.005 grams. And in the accompanying assignment here and in your ALEX, you will be able to deal with those conversions. English units, these again come up a lot and maybe ones that you are more familiar with, but in science, to be honest, they really don't come up all that much. The principle is the same. There is a conversion that we have, and we're going to look at how to use these conversions to translate one quantity unit to another in our homework that we're dealing with. Temperature scales, these also matter somewhat, right? We haven't really talked about temperature because the temperature scales are a little bit different. And I won't go into too much about how these all came about, but if you want to discuss that, I'd be more than happy to. Fahrenheit is what we deal with in the sort of day-to-day discussion, but Celsius is the fundamental scale that we deal with in science and healthcare and around the world. Converting from one to the other is really important. Fahrenheit has a boiling point of water at 212 and a freezing point at 32 Fahrenheit, whereas Celsius really smooths this scale in a lot of ways and makes it from a 0 to 100 scale, with the boiling point of water being that top level that in a practical sense we kind of stick around. 37 degrees Celsius normal body temperature, that's a good one to keep in mind. Kelvin scale we won't deal with so much here, but that one really does have an absolute 0 that we are obeying for the Kelvin scale. Here's our formulas for converting Celsius to Fahrenheit, Fahrenheit to Celsius. They're a little cumbersome, and ideally you won't have to do this too much, but you can always convert from one to another. If you have the temperature in Fahrenheit, you can get the temperature in Celsius, and this is the method through which you would do